George. George? Daniel is not here.
Good evening and welcome to the sixth episode of Hort Forum. We will discuss today scientific research in the field of horticulture to meet academic goals versus research to directly address industry needs. The goal is to address a topic that rarely gets openly discussed, but is very important to understand for researchers who hope to have a profession in horticultural research. The Hort Forum will address this tension, and a small panel of senior horticulturalists will present their views and experiences in how they have dealt with these issues. In addition, two members of the ISHS Young Minds Committee will respond to the presentations. Finally, the panelists will respond to comments, questions from the online audience. For people from the audience who are not familiar with the format of these episodes, just to let you know that if you have any question, you can put it in the Q&A section, and thereafter the panelist or the main speaker will try to address your question. The panelists today are Stephania de Pascale from University of Napoli, Daniel Leskovar from Texas A&M University, Francois, Lawrence, and Patricia Pavia under their capacity as President and Vice President of ISHS. And also we have the pleasure today to host two young researchers at the PhD level, Chayce Griffith from Michigan State University and Matra Nunes da Silva from the Portuguese Catholic University. Our speaker today is very special, Ted DeJong, Emeritus Professor at the University of California at Davis, who among others is a fellow of ASHS and ISHS, and currently serving in our society as Vice President in charge of the scientific programs. Ted, the floor is yours.
Thank you, George, and welcome to all of you. Thank you very much for those of you who are attending. And today we're going to discuss a bit about research and the two different things that we have to address as horticulturists. And a little background on this. Way back in 2018, I participated in the ISHS summer school with Jens Winsche and Chris Watkins. And we were the main lecturers for that course. It was a 2-week course. And during that summer school, each student made a brief presentation of the research they were engaged in. And from my perspective, most of the students were focused on addressing specific grower-oriented issues, but very few of the students actually engaged in science, and they didn't realize it. So from my perspective, they didn't engage in science. And I might add, I routinely am disappointed with many of the talks at ISHS meetings because many of them are not very science focused, to be honest. This prompted me to write the Chronica article a while back, and it's going to be a topic of today's discussion. So my observations about categories of research, basically, they run the gamut from being purely observational or testing performance of a new technology. And many are testing the effect of and blah, blah, blah. And I suggest that for any of the young people who are listening, I highly recommend that you don't begin the title of your paper the effect of blah, blah, blah. It gives away right away that you basically have a descriptive research. So asking specific questions, so another type of research, asking specific question based on previous observations or hypotheses or the literature, or testing hypotheses that are based on previous observations and theories. So these are all different types of research. The first two categories, I would say, are simply descriptive. They may be of interest to growers or to our constituents. the last two involve science, that is, making and testing hypotheses. And not all research is science. I think that we need to recognize that. So when I used to teach a graduate class of incoming graduate students, and we used to give them, me and my colleague taught the class together. We used to give them the very first day of class, we gave them a quiz that had 5 questions on it. And these are 2 of the questions. They were 2 true-false questions. Science provides access to ultimate truths, true or false. In scientific experiments characterized by exceedingly clear thinking, hypotheses are proven and are subsequently considered facts. So you guys can give yourself that little quiz, and I'll provide the answers. The first one, science provides access to ultimate truths. That's false. Science provides ever closer approximations to truth, but we're really not after the truth as it's normally thought of. Science involves continuous refinement of hypotheses. Interestingly, science is more about searching for truth in the natural world. Religion is more about asserting truth through non-scientific means. So in science, we're not actually after the ultimate truth. In experiments characterized by exceedingly clear thinking, hypotheses are proven and are subsequently considered facts. This is also false. Hypotheses are mainly statements of the status of our current knowledge and thinking. Hypotheses are continually being refined, reformulated in response to experimental tests and new data. And finding conditions under which an hypothesis does not hold forces one to refine or abandon the hypothesis. So basically, I would argue that science is basically in pursuit of understanding of nature, and in that we develop hypotheses. Now, most of us gradually accept these things as truth, but simple things such as, not simple things, but concepts such as photosynthesis even, is not really something that's observed. It's something that we have over the last 150 years refined and refined and refined and refined further. But it's really not really a fact at this point. It's still a theory. So science versus empiricism. So science is systematic study of structure, behavior, physical and natural world through observation, experimentation, and testing theories against the evidence obtained. And I'm sure all of you know these basic steps for scientific research. You ask a question, you do the background research, look at the literature and everything, you develop a hypothesis, you develop construct an experiment to test a hypothesis, then you analyze the data and you draw conclusions. And empiricism is basically the practice of relying on observation and experiments in natural sciences. It's basically descriptive research. The goal of science, this is probably where some people would object. The goal of science is to establish and refine theories. The goal of empiricism is to establish facts based on observations. So why does this matter? Why are we discussing it? Because I think over the years, I've come to the conclusion that we basically, a good horticulturist in the academic world or in research in general, basically has 2 masters. We have the farmers or practitioners who value the practical results, regardless of whether they come from science or descriptive research. And we have fellow academics who value scientific progress that is primarily testing and refining hypotheses. Our public constituents are more interested in what works than theories or proofs. So this whole business of science and not really establishing fact is probably viewed a bit esoteric, but that's the way it works. Academics are more interested in advancement of knowledge and development, testing hypotheses. And our public constituents judge us based on practical deliverables. Academics in academia were basically judged on our publications, impact factors, and individual H indices. So we basically have these two things tugging at us in our career. And I might add that research, many of the main journals for our science are looking for papers that are hypothesis-based and developing knowledge, not necessarily practical results all the time. So I think that we as horticulture or academics, we need to train students how to do science. However, at the same time, we can't discard observational research that can deliver empirical evidence for the development of new technologies. So this creates a tension. They're not mutually exclusive. How we frame our research is important. Journals with high impact factors generally favor papers that document testing and refining hypotheses. So for any young scientists here in the audience, I'd suggest that you write your paper, pose your question, state your hypotheses, and proceed in that way. And don't title your paper "The Effect of blank, blank, blank." You'll find it much easier to publish this kind of paper. But practitioners and horticultural clients favor delivery of technologies. They don't care if the results are obtained using scientific methods or simply observations. So this creates a bit of a thing. So the goal of the Hort Forum will be to discuss this tension. And after I make a brief presentation, each panelist will respond to what I have to say. And following that, we'll ask for comments from the audience or comments from each other. And I'd encourage people to be willing to disagree or express their concern about what I'm saying. So first, I'll give a few examples from my research about testing hypotheses and other research that was more descriptive. First one is an example of how information developed from fundamental research has led to understand how trees work and concrete recommendations for improving management practices. So many years ago, and anybody familiar with peach fruit growth for many years, ever since the early 1900s, people have been fascinated by the fact that the peaches, if you express, this is on a dry weight basis, is cumulative dry weight on the growth of an O. Henry peach, a late maturing peach. This is based on dry weight. If you do it on fresh weight, this is much more pronounced, but it's well known in the literature, and people have been studying this for years and years, that the peach growth starts, it's what they call double sigmoid growth. You have a relatively rapid period. You have a period where there's a little bit slacking in growth, and there's been then a second period, stage 3, where you have rapid growth again. And this is the thing that almost everybody in the literature, if they talk about peach growth, they talk about this. That is rapid, slow, rapid. Almost everybody ignores the fact that on early peaches, you have only rapid growth. And this middle phase is basically eliminated. But that's not really part of it. But the thing is, way back in the 80s, we recognized that we could model this growth using relative growth rates. This is a natural log of the relative growth rate. If we did that, basically whether it's this one or this one, you could model it as two basic stages or phases. One where it's a rapidly descending relative growth rate. Relative growth rate is basically compound interest rate for those not familiar with it. Anyway, rapidly descended relative growth rate, and then a fairly leveling out of relative growth rate. And it doesn't matter whether you have an early or a late peach, you can model them in a similar fashion. It's just the timing of when this curve, when it transitions from this phase to this phase. So, and this point of transition, if we do a simple calculation model, the point of this, when this transition occurs, whether it's at 400 degrees or 500 or 600 or 700 or 800, creates a different kind of absolute growth, cumulative growth rate curve. So this one would correspond to this one, and approximately this one would correspond to that one. So basically the same model, just when the transition occurs. So we looked at that, and this led us to do a whole bunch of experiments. Oops, sorry. Looking at other fruits. So these are two other cultivars, but roughly this is a little earlier than the June Lady one. This is same timing as the Henry one, but basically did it again. This curve is ones where the trees were heavily thinned, and these were not. Let's only look at this curve. So you see the same sort of double sigmoid curve. If you plot this cumulative dry weight curve as absolute growth rate, that is grams per unit time, then you see the double sigmoid pattern very clearly, and it disappears with this one. But then if you plot those same things as a relative growth rate, you see the same curve as before, except we have it as a continual curve here as on the previous slide. So basically what this tells us is that, and if the tree is heavily thinned and the fruit can grow according to their potential, this forms a pattern for modeling the potential relative growth rate of the fruit. This turned out to be a very valuable concept. So this is all the hypothetical part of the thing. So we turned around and did, okay, if that's the case, then if we thin trees at 5 different times, at bloom, a month after bloom, a month later and a month later, and left some unthinned, we get these 5 curves corresponding to these thinning times. And you'll note 2 things. Because the potential relative growth rate is fixed, so that fixes the potential growth rate at any time. So the time of thinning, you notice that all these curves are almost parallel with each other. But very importantly, if you thin later, the fruit never go back to where it could have been with the ones growing earlier. So this tells us that the earlier you thin, the more chance you have of getting large size fruit. So we then did a couple field experiments, 2 years in a row, where we thinned peaches at 3 different times in this case. And then we looked at, and we thinned them. We thought we were thinning them down to a similar crop load, but in this last case, in May 23, it was a lot less. But you'll note that the fruit size on this one versus this one, this is the mean fruit size, is the same, even though there were 250 fruit fewer, almost 300 fruit fewer. And the yield was substantially greater the earlier we thinned with larger size fruit. So we did this repeatedly with different varieties, and here with 3 other varieties in another year, in the second year, same thing. If we thin to the same level, we get larger size and much greater yield. If we thin to a lower level, yeah. So this works in the field, and for this reason, previous to this, almost all the processing peaches were thinned in May in California because of an old rule that they used. By doing this, we recommended that they thin earlier, and they gained substantial amounts of yield in doing so. So all this theoretical work ended up providing practical recommendations for growers. So in addition, this led to the working hypothesis of how carbon is distributed in fruit trees, and is what we used in our L-Peach model. And because the fruit is such a large sink, we basically developed this hierarchy of understanding fruit carbon distribution in trees. So the way I view a tree is a collection of semi-autonomous organs, and each organ has its own developmental pattern. And in the case of fruit growth, it's relative growth rates. So the organ development and growth is activated in the beginning of the season by endogenous hormones or endogenous signals, potentially hormones or environmental signals. Once activated, organ development creates the conditional growth capacity, and that's driven by the relative growth rate function. And then realized organ growth at any time interval is a consequence of this capacity and the resource availability in any inter-organ competition. And then the inter-organ competition for carbohydrates is a function of the location relative to other sources and sinks, transport resistances, and so forth. This is all baked into our simulation model. So this is a simulation model of fruit growth. I hope it comes out on your computers. On the left, we have one with the L-Peach model where the tree is growing with periodic drought, and the control is well watered. And in this model, we spent about 25 years developing this model, and the model simulates the photosynthesis of each leaf and distributes carbons around the tree as a function of those things I just talked about. So we also prune the tree. In this case, the tree was just pruned. So we can, it models, yeah, get rid of that thing. So at the end of each year, we can prune it. And now we're getting, and you see the tree on the right goes under a little bit of stress. One on the left. If you note, the fruit sizes are different. The reason why the fruit sizes are different is because the fruit sizes are driven by the same principle as I just told you about. So after each year, we stopped after each year of growth, we stopped the simulation and pruned the tree, and then started again. So that's just a summary of some of the hypothesis-driven research that we've done, and it's interesting. None of this theoretical stuff, unless I had a actual practical outcome to tell growers about, the growers were never interested in it. But when I began showing these movies of the simulation model, they suddenly got more interested. So that's one way. If you want to do just theoretical stuff, then create a visual thing for growers to see. So on the other hand, that was more my theoretical research that I did. We did a bunch of empirical research also, training system, rootstocks, and variety development. So those of you who know the pomology side of this, we developed a perpendicular V orchard system and so on, and did a bunch of research. And that research basically was based on some principles of physiology, but the practical part of it was all just field tests. And we also cling peach variety that happened to be a bud sport. And this variety, we tested it and so on and released it, patented it. And this was a late Ross, and it became the second most planted cling peach variety in California. I also have been overseeing a prune breeding program, which is mainly descriptive research. We developed in that process a fresh market plum. Tulare Giant became the most important fresh market plum, European type plum grown in California for many years. And then along with my colleagues, we've done a lot of research looking at rootstocks. And we released these two, P3135 and HBOC 27, which is controller 9 and controller 6, and released them to growers, and they are now being used in California for growing peaches. So this is some of the practical, direct, descriptive type research that we did. So kind of a historical perspective of what I've done, in that on the theoretical side, I published about 300 scientific paper, journal articles, and conference papers, most of which were more science-based. At the same time, I'm involved in the development of all these other things, rootstocks, cultivars, and training systems. So I'm at the end of my career. I've been retired from the university now for 8 years. And I've kind of been looking back and assessing what was most important to me and most satisfying. So the science-based research has given me academic promotions and some recognition in the scientific community. And the result and the work that resulted in practical recommendations to growers was very satisfying, to say that. However, the technology development research is probably more directly consequential to California growers. So with that, I personally believe that horticulturists, we need to engage in solid hypothesis testing research, but also recognize the value of development of new technologies, whether they are based on science or empiricism. But we also have to recognize the difference, and particularly to train students on how to do the former, in addition to how to properly test technologies that we might develop. But the development of these technologies can sometimes be more serendipity than it is actual science. That is, for instance, the cling peach that we released happened to be a bud sport that came up in a large trial that we did testing training systems. So with that brief introduction, we'll start the panel discussion. And these are the people involved. And I put these questions to the panelists. They can answer any one or all of any of these questions. I just put these questions out here. I'll leave them on there for people. And we'll begin the discussion.
Thank you, Ted. I would recommend to read the questions and to remove your presentation in order to have full screen the panelists, if possible. So
You want me
you
to-
might posing the questions and then just remove your presentation in order to have full access to the person who is
Okay, I'll stop sharing.
Okay. Okay, excellent. So I will give the floor initially to Stephania. Stephania, among others, she is a very active member of the ICHS under different roles. So I think is one of the most appropriate persons to discuss on the topic we have raised today. Stephania.
Thank you, Ted, for initiating this really engaging discussion. Okay, I will try to give my classification of research based on a long-term. I am a long-time researcher in Italy, and in my opinion, research in horticultural science can be classified into two main categories: basic or fundamental research, that is the most theoretical form of research aimed at expanding scientific knowledge without an immediate practical objective, and applied research aiming and funding practical solutions to specific problems or developing new products and technologies. So both categories are valuable if they are hypothesis driven and the research follows the standard of scientific method instead of being what I simply call spray and pray experiments. So, but after the research phase, the process of transforming knowledge into concrete applications continues through several additional phases, key phases. And in agriculture, these key phases are clearly defined as agricultural extension, which is the application of scientific research and new knowledge to agricultural practices. In my opinion, the different figures, scientists and extensionists, hold the equal importance, but they have distinct objectives. And this distinction is fundamental as research aims to acquire new knowledge. So what is happening today? In my opinion, the research system is mixing, especially the funding system of research in Europe is mixing all, expecting scientists to manage all phases from basic research to technology transfer and training for farmers. So this is an inefficient approach to achieving two valuable goals: producing high quality science and transferring new knowledge to make agricultural business more profitable as well as more environmentally and socially sustainable. As a result, young researchers in horticulture are frequently drawn to empirical research. Okay, I agree that the practical orientation is valuable, but it may come at the expense of engagement with scientific methods and hypothesis testing, especially considering the current competitive academic environment driven by a publish or perish culture and the rise of what we call predatory journals that often boast high metrics and very questionable quick review processes. So as a result, we have a kind of circular system like a dog chasing its tail, and this negatively impacts the research system and creates a snowball effect that lowers the overall quality of science. So I think that for young scientists starting their careers, it is essential to find a balance between scientific inquiry and practical application. But the research should be in all cases driven by hypothesis and should adhere to rigorous standards. I think that I don't have time anymore, but otherwise I can.
That's great, Stephania. I fully agree with everything you said. I would like to highlight what you mentioned about predatory journals.
Yeah.
I'm fully aware about this issue. And personally, this is my personal agenda, and what I can suggest also to the early stage researchers is to try to avoid this type of journals that they're being promoted as high impact factor, but the very fast peer reviewing process is really questionable to what extent is appropriate. And also, at least for Europe, when you receive a grant from a European Commission, you must have open access. So, for example, it's really surprising. It's not eligible cost to have publication in a hybrid journal. It should be fully open access. And under my capacity as editor-in-chief in Scientia Horticultura, this journal, they received the decision, who is receiving 4,000 submissions per year, to switch to open access. Maybe this is one of the reasons. So I will now give the floor to
Georgios, you can, in Europe at least, our research funding system often requires addressing specific challenges faced by farmers and even ensuring their direct participation in the research project. And this can lead to the problem that Ted mentioned before. So 2 masters, and so 2 bad results for both of the masters. Francois is raising his hand.
Yes, Francois, please.
Thank you.
On the topic of predatory journals, for sure, we have to be against. But since you made the advertisement on the Scientia Horticultura, I made the advertisement of the new journal we launched with the ISHS, the new European Journal for Horticultural Science, which is not at all a predatory journal. And so
definitely.
Parenthesis.
Okay. So I will now give the floor to Professor Leskovar. Daniel, the floor is yours.
Thank you, Giorgio, and thank you, Ted, for the excellent framework, and also happy to be with distinguished colleagues here today. So, just for those who don't know, Daniel Leskovar, I'm a professor in vegetable physiology and production. At the same time, I also hold some administrative roles. I'm the director of 2 centers. Centers that are not on the main campus. These are experiment stations. One is in a very rural area, working closely with the growers. This is in Uvalde, west from San Antonio. And the other is actually very urban environment, which is located in Dallas. So then you have these 2 frameworks that allow us to really engage in some sort of more empirical research if we are serving the clientele. So following the discussion of presentation, so my area of research specific is trying to understand how plants behave or adapt to environmental stresses, whether it's temperature, high temperature, and drought particularly. And they're looking at the morphology, physiology, and metabolic aspects related to that. And then use that information for the development of some sort of sustainable systems, vegetable systems, making more resilient. So with that, obviously, the allows our program and our students to be kind of engaged in both aspects. So the question is very valid, obviously, classical, basic versus applied, the fundamental, theoretical versus, again, more type of, empirical research that gives some potential opportunities for implementation. So I think the merging between the 2 basically is translational research, and we feel that what we're doing, at least in some of us, is doing a translational research that then we can adapt the type of research depending of course, of the question, right? The knowledge gap, the importance, and the outcome. But there are differences between the two, obviously, between basic and more applied research. Differences in time, short versus long term. Differences in methodology, like Ted showed how more detail or focus could be in a more theoretical work versus applied. There is also a difference in the focus now, whether you involve one or two disciplines or multi-disciplines. And then, of course, the outcome is very different. So the outcomes, publications versus implementation and practices. So I think we have to put that into the context within the type of a question that how you address the question and then follow that up. And also depends also on mentorship and students' interest. So there's a difference between master students or PhD students, right? So we will have, I normally try to give them the opening just to see how curiosity drives them to develop some certain questions, how deep or not, maybe observational. And based on that, try to cultivate that and then adapt for the particular programs. If it's a master's, typically that'll be much more applied type, but if it's PhD, it's more translational in nature. So again, I think there are a lot of opportunities to merge the two and then being less concerned about this either or, just to make sure that, like the example of Ted, that theoretical work led to some applications, whether it's new management or new technologies or developing new varieties. So yeah, I will stop here and then give the floor to others, but very, very enthusiastic to listening and engage in the conversation.
Thank you very much.
I want to break in here a minute. I recognize that Daniel was a former executive division executive chair in ISHS, and he's now currently the president of ASHS, the American Society. Oh, I just wanted to recognize Daniel. He's a very important person.
Thank you, Ted. You too.
Okay,
congratulations.
Okay, let's move and give the floor to Patricia Pavia, ISHS Vice President. Patricia.
Hello. Thank you, Ted, for this nice presentation and raise this theme that is, I don't think it's attention, but it's very important to discuss about that because you are changing the world and you have new ideas, new positions for this theme, what's science, what's not science. Well, I'm a professor at Federal University of Lavras in Brazil. It's another reality. We're talking in Brazil, in South America. And in my university, I used to be a coordinator of graduate program, master and PhD. And also I used to teach a course on scientific writing and to teach students how to prepare their project, how to prepare their article. And I have to say it was not easy because I think students do not have anymore some courses on science. They just start science. Think that they're starting their research doing science. They do not have anymore any kind of preparation for that. So having to fix and to teach them how to prepare their research, their project, and anything else. Well, I try to answer I choose some questions from TED, and I choose one that I think will be relevant to expose our situation, specifically the Brazilian situation. For example, you ask about what type of research do you feel is most satisfying? What's happened now is that we have many calls for financial support for research, and all the calls they request us to connect our research, our proposal with industry, and some of them with growers. So you must involve industry and growers in a research project. So this is a kind of, well, how can I conduct this? Because I have to do a research for industry, for their interest and the growers' interest. And if you're not involved, you cannot apply, you don't have money. Also, one thing that you have to answer in this proposal is the impact of our research on the society. How does we impact? So we must produce to have results for the society in order to have a financial support. This is our reality for the last years. So this is one point. I'm not saying it's not correct, but this is the situation. I'd like to just expose that. Another point that I'd like to expose is that what I used to say or made to say to students start a career in Hort Forum research. What I realized I see with the students in this course that I used to lecture in the past is that in the students' mind, what they think first is which species I will work with. Doesn't matter if you have a problem, but they select the species. And I have a situation of one student that selected, I work with ornamental, so this is worse the situation because ornamental you have some beautiful colors in the flower. And this student answered me, I would like to work with this species because my mother liked it. So it's common. He was not laughing, but it's a situation. And then the second point is that they want to test anything. I want to test this in this species. This is the way how the students think in preparing their project. So the most difficult thing is to change the students' mind. How they can think in different way? Well, you start to think in a problem, and let's start to solve a problem. So after that, you must to ask questions. So prepare the hypothesis and ask questions. What happened? How can I solve? What happened if I try this? It's not easy to do that. One thing that I start to do is when the students prepare the aim of their project or article, please insert some questions. Besides of the objective, ask some questions. At the end, you must to answer these questions. It's a good way to try them to test on a hypothesis and to see in a different way to prepare the research. And there's another question, what type of research are most recognized for? I agree with Stephania, you have to find a balance because in the way, I only have financial support if I prepare something that you attend, provide results for growers, for companies, and supply sites. In the other hand, I need to transform this in a scientific way to publish the papers. So you have to do this balance. Sometimes you must to test something to have results, but on the other hand, you must insert questions. Why, how, and then test them to prepare the papers. So this is what we are doing. This is the way we must do in our country, in our research, mainly to do this, to find this balance in the situation. Okay, thank you very much. This is my contribution for this first half.
Thank you very much, Patricia. Francois, the floor is yours.
Yeah, thank you, George. Thank you also, Ted, for organizing all this series of Hort Forum. I'm not sure, Ted. So, and a special thank for you, Ted, to organize this, to raise this specific question. I think it's one of the important things we have to discuss at the level of ISHS and particularly on horticulture. So thank you very much. So I'm the president of ISHS, but my real job is is a geneticist and breeders, I would say, and I started to make more upstream research, so publishing and doing also some very applied research, releasing varieties. So I think I know a little bit both aspects. And it's good to speak after you, all of you. So I don't have much to say. And I really appreciate the definition you gave, Ted, and the different points you raised. So I agree about your categorization. I don't think, on my view, is that I don't think there are much tension between these two aspects. At least on my view and in my country, I think also this question can depend on the country. In my country, we have I don't know. Yeah, I'm from France. I'm not sure that France is the best country, the best organized country, but at least on research, we have on one side what we call what you manage, Daniel, sort of experimental units or technical institutes, which are 100% on applied research. On the other side, you have university, which are normally 100% science. And in the middle, we have a sort of the institute I am, INRA, which is an agronomic institute, which is both upstream and applied. And in this institute, you have what we call pure scientists, which should do only upstream research, and what we call research engineer or something like that, which can do research or applied research. So it's different kind of people. And I think what is important, I disagree a little bit of what you said, Stephania. I don't know if it's actually what you said, but what I understood from it, we said, I don't think that one guy can do everything. If he can do, okay, it's good. But for me, the best way is and it's what we try to do at the level of ISHS, to work as a network. And so if you are in a research unit, the good team is to have all people, the one who are doing the upstream and the one who are doing the applied, and to have this, what Daniel, you call translational or something like that. I think the most important, the key point, if you can get these different people, is to be able to do a good transfer from the upstream to the application, which is, I think, the key point. For me, the key point is not is it good or not to be a upstream scientist or academic one or applied one? The good thing is to make the system working. And for me, the key point, at least for me, is really the transfer. I have a lot of examples where you have a lot of good, very upstream research with a lot of papers, excellent papers on biocontrol, for example. But and people who need these products, but there's something which we block in the middle. So I think it's something. And to just two examples more on the genetics on apple. I'm working mainly on apple. I have a very good example of what our colleagues from New Zealand did. They really did excellent work on red flesh apple, the genomic of red flesh, looking at the mechanism, the really high-level papers on one side. And the other side, the breeders release apple, red flesh apple. So this is a really good, I think for me, it's a very excellent work. We did a little bit the same at a different level in my lab. We used to work on scald on apple, sort of a disorder of apple. And we really did, from a very basic, practical issue, we really succeed to publish really good papers. So I think, for me, Ted, there's no big tension between the two. And I don't, to answer one of your questions, I don't have really, I can't say to the young people, you should do that or that. It's really you, how you feel. And if you feel more practical, do practical research. And you can do, actually, for me, the rules are the same. We need rigor. We need a very scientific rigor, scientific process for both. The only point is, do you want to publish or do you want to application? And we speak about.
Thank you very much, Francois. Thank you very much. I would like now to move to the two early stage researchers. We selected one from Europe and one from the United States. And the reason is also, among others, not only for geographical representation, but also due to the fact that in the United States, there is industry in horticultural science behind to support, to fund PhD projects. This is not so often, I would say a little bit rare in Europe. So I will initially give the floor to Chayce.
Yes, thank you. Yes, I'm in my position in the United States. I'm a PhD student at Michigan State University, working with Todd Einhorn on Honeycrisp apple. And I say Honeycrisp specifically because the apple industry in Michigan cares so much about that specific cultivar. So when I arrived on campus, I didn't know what sort of project I was going to be working on, but I knew it was going to be an apple because that's what our industry needs more research done on. And as a result, that's where we're going to be getting funding. And then you move down a step from that, and I know that I'm going to be working on a Honeycrisp because that is the cultivar that matters the most to the Michigan industry right now. And then from there, the industry told us what their biggest concern was when it came to Honeycrisp, and the biggest concern was how many Honeycrisp fruit are ruined with bitter pit every year. So right off the bat, I've pretty much had a project assigned to me directly based on what the industry needed. And from there, it becomes my responsibility to approach the project in a scientific manner. And so I need to develop a hypothesis based on bitter pit. So when we talk about that tension between what the industry needs and what the industry is willing to provide funding for, in my case, and the actual scientific method in doing things in a focused hypothesis-driven system, there really wasn't much tension in my case, and there really isn't in my work, because I'm given a problem based on what the industry needs, but everything after that is up to me to approach in that hypothesis-driven manner. And so, yes, our system has complications to it where you are really only able to conduct research that the industry is going to be willing to fund. And that does put us in a corner sometimes because we get focused on only very specific species that matter to our industry and only problems that they can really understand directly. But at the same time, I think it prevents us from going down rabbit holes that are not helpful to our industry. That being said, I think that with our research that we do in the state of Michigan, we're limited to those numbers of crops that we have, but there are still instances that I see sometimes researchers presenting projects that are on one of those crops that we would definitely care about in the state of Michigan. But at the same time, it's not necessarily a problem that they're addressing that the industry has. And so I wonder sometimes if the growers, when we're presenting that data to them, are seeing that and thinking, yes, that's where my research funding is going to, is understanding the mechanism of this one particular gene that has to do with something in a crop that I don't actually grow. I think it can be difficult to explain to growers why that research still matters, because a lot of my bitter pit research is based off of other calcium deficiency disorders in crops that these growers in Michigan don't necessarily care about. But like I said before, it's then my responsibility to say that research was helpful because it set the stage. That basic research was important for me to be able to then create fundamental applied research in apple and say, see, this is how I'm able to translate that into something that's actually useful to you. So I think that's a big part of our responsibility as scientists, is not just to come up with these hypotheses and study them rigorously, but also to communicate to our stakeholders and say, this is where you come into that. This is how the research that I'm doing might not seem immediately valuable to you, but I promise it is, and here's why. It's our job to put it in those terms.
Excellent. Thank you very much, Chayce. I will give now the floor to Matra.
Hello, everyone. So as a young scientist, my scenario is a little bit different from Chayce. I'm a plant biologist. I have a PhD in agronomy, and I finished my PhD 3 years ago. So now I'm a doctorate researcher in a Portuguese university, the Catholic University of Portugal, and I also am an invited assistant professor in biology and genetics. And my main research lines are plant ecophysiology, crop protection, and genotype environment interactions. So I do a lot of spray and pray research, but I like to know the why it works. Why is a genotype more resilient to water stress or to a disease than another? How can we lever its intrinsic defensive capacity by manipulating the regulatory mechanisms? Why did this product was efficient in improving plant productivity or resilience? And why the other didn't function? How can we boost even more the one that functioned? So I like to understand how things work so that we can improve crop management and orchard management. So in my particular case, I wouldn't describe the relationship between academia and practitioners and farmers as one of tension, but rather as a gap in dialogue and in understanding. In my point of view, academic research and industry-driven research are complementary, but they often operate in different timelines and they measure the degree of success in a very different way. So I believe that to bridge this gap, we need a lot of reforms regarding our funding systems and also our education systems. So following on what Stephania said, I believe that the European Union wants to boost the translation of scientific findings into the people that need these findings. They are funding even more projects that rely on citizen science, which I don't know if you are familiar with. Citizen science is when researchers go to farmers, to value chain actors. They explain what they need to measure to boost or analyze the value chain as a whole. And then the practitioners and the value chain actors, they report to the researchers that formulate a report on how to boost that value chain in different locations. And this is a very good step to improve the application of science to agriculture and horticulture. However, one of the things that I believe it's missing in this translation system is the way we researchers communicate our findings, because we have to rely on certain index of productivity, which are the H index that Ted referred to, our publications, our communications, and we need this to progress in our career. But most of our papers are not accessible to farmers, to producers. They don't know how to find them. They don't know how to read them because they are very technical. So we are losing a lot of good science in translation. We need to find new ways to deliver our knowledge to who needs them, to the people that need them, and how to recover their feedback and to keep this feedback loop in our projects, to keep enhancing and working together to a common goal. So I believe that we need to reform a little bit our funding schemes and also our educational curricular, because has Ted said, not Ted, yes, I believe that Ted said, and that Daniel also said something to do with it. I believe that, and now that I'm also a teacher, I went from student to teacher for a very briefly moment. So I find that there was a change in the students' mentality comparing to when I was a student, which is not very long ago. I find that the students now lack scientific curiosity. They don't know how to innovate. They are used to being fed the information, and they don't need to rely on their critical thinking and on their filtering capacity to reach the information that they want and to formulate the new hypotheses that could create new concepts or new products. So I also believe that we need to reform our education system somehow. I believe that our current evaluation system is not very beneficial to this because we keep relying on standardized testing to assess our students. And I think that we should introduce new curricula that makes them think from themselves, that makes them create new ideas to develop projects to improve their communication capacity. So when they arrive to the job market, they know how to collect the relevant information from the people that are involved in it and formulate a question and possibly a solution to the problem at hand. So I believe this is the comment I have for now. I covered a lot of your stuff, but I want to engage even more in your discussions, and I want to reply to some of the questions from the audience as well.
Excellent, excellent. Francois wants to discuss the type of funding and how this is affecting the type of research that we're conducting.
Actually, Marta sort of said what I wanted to say. I'm really impressed by your two presentations because you have a real good view on what is research. You raise an excellent point about fundings, and for sure fundings influence what kind of research you are doing. So you are in two very different situations and with two levels of application. Marta, you also raised the problem of communication. I don't know if you heard about what happened in my country last week. Actually, the growers went and blocked my institute because there are lack of communication between what my boss are saying on agroecology. Ted will be happy about that. And they actually ask what we are doing. And so, and you also raised the point. If you do upstream research, it's very difficult to communicate to the people who apply it. So we had a big discussion yesterday about this point. So thank you very much for that. So
adding on what Francois said, I don't know if I can intervene anymore. Earlier this year, I was invited to give a talk in a farmers association in Portugal, the kiwi fruit producers. And I struggled for a few weeks because I didn't know what I would say to these farmers because I never delivered presentations to non-academic or non-scientific audiences. So I picked my brain for a while. Then I thought about making a presentation about agrochemicals, plant enhancers, of productivity enhancers or disease resilience enhancers. And my presentation was on the mechanisms by which these products, these agrochemicals work, how they, what they did inside the plant to deliver the expected results. And so I explained the products, their constituents, what they did inside the plants in terms of gene expression, of metabolomics. And after a while, I thought, well, maybe they are bored about my presentation because no one said anything. But in the end of the talk, people came to me, farmers came to me, and they were grateful for the presentation because they use these products on a daily basis and they didn't know how they work. So we clearly need to improve our communication with the people that can harness our scientific work. So we have a lot to do regarding this. Yeah.
Thank you very much, Marta. I'm quite happy to see in the attendees several senior people also meet industry needs and their knowledge also develop new products. I would like initially to give the floor to Professor Alan Laxo to raise very briefly 2 or 3 points linked to the topic.
Thank you. Can everybody hear all right?
Yes, very clear.
Okay. Thank you. Yeah, very interesting discussion. I think Ted's introduction brings up a lot of very good points. Just one I'd like to mention in terms of thinking about how we fit in the system of science and application. Many times we talk about basic research and applied research. But there's something in between, which I think is where we belong. And I might call it fundamental research or something like that, where we may be using the same techniques, we may be using the same types of measurements, approaches, and developing similar theories as really basic people who don't have any application in mind. But I think it works best for us if we're actually working on, well, we're horticulturists, so we do work on specific crops, not just test plants. So we work on specific crops, and also in many cases, if we know what the problems are in the field, we'll be working on some more supposedly basic physiology or genetics, but it has a direct application, or at least potentially a direct application in the field. So I think we really fit in that kind of middle ground, and that it's not basic or just applied. I mean, we may be just applied, but in a lot of cases, I think we kind of fit in between, and then we make that stretch by using or working with colleagues that are more in the basic area, more in the applied area. And that interaction, I think, is really important to work on useful fundamental physiology or genetics that has application, because we come at it from that standpoint. And then just another thing, that with a lot of new technologies, especially things like remote sensing and precision agriculture, there's a lot of technology development, and you see a lot of papers, say remote sensing of, could be a disease, it could be physiology, drought stress, or things like that. The one thing that kind of bothers me is many times you read it and they say, we did this on a vineyard or an apple orchard or a crop, and it worked fairly well. Many times R squared 70%, maybe 80% R squared, but there's never or rarely is there a statement of what are the limitations. And when we do something that we ultimately would like the growers to be able to utilize, it's important that we actually, we look at our results and then say, as Ted pointed out, is that really going to help all the time? Is it going to work in a different situation? So if you have a plant that has a very wide space and you do remote sensing, you can see all the leaves. But if you're dealing in a vineyard that's extremely narrow and you're flying overhead, you only see the very narrow top of the canopy, and it won't work nearly as well in many cases. So I think it's important to, as we develop technologies, to be really skeptical and try to understand, as Ted said, when is it not going to work? And that will help us improve our understanding, the new technology, or at least be able to tell the people it will not necessarily work in every case. So anyway, thank you.
Thank you very much, Professor Laxo, for your statement. I was wondering if Angelo Zanella is hearing us. Angelo is, I have first-hand experience because he managed to develop a new post-harvest technology for apples and pears. And I was wondering if, yes, Angelo.
Do you hear me?
Yes, if you open the camera, it will be great as well.
I have a very bad connection here.
Okay.
I'm traveling.
Okay, so I would like to highlight, because your contribution to address industry needs is very important.
So you have to help me because I couldn't hear you before.
Okay. Okay. So basically, we discussed how we can meet research with industry needs. And I think that your case with the dynamic control atmosphere is an excellent example to present.
Yes, it was in fact, it was the development was pushed very much, but the need of the commercial reality to find find an alternative to losing a lot of quality, also crops, and also to the, let's say, to the risk of having no alternatives because of the ban of DPA that has been then also being applied by the European Union. So let's say that it was pushing very much the direction of the research, this need from the commercial reality. I have to mention that also the mission of the Research Center Limburg, where I work, is to support the commercial reality, and we are also funded in a way that we can partially work for longer time on specific issues. So we don't have to rely on projects that have limited time finance.
Angelo, thank you very much.
George, I have a comment responding to Francois a bit. So Francois is in IRTA, which is a very large organization, and they tend to they're organized into teams and large teams working on an individual project. But many of us in horticulture are in academia, where we have not such a large team. We tend to be much more independent operators. And you have to be able to, in that case, the same person has to do both the applied and the more field-oriented and the very hypothetical or theoretical science. So I think each of us has a different situation. If you're in academia, I'm guessing that you have to bridge that gap, more of that gap yourself, and you can't rely on other people in your team to do basic, and you're doing the applied part, and everybody works as a team. I think that's a big difference between some of our situations. And I would also argue today, what I see in academia particularly is this notion of, okay, they want to be on a team. But the problem we have is in 40 years ago, 50 years ago, almost everybody that came into academia, into horticulture, agronomy, and so on, came from or had some experience with a farming background. Now, 99 and 95% of the people that come into our horticulture and agriculture departments have no farming background, and then they get enamored with some fairly basic fundamental research, especially in genomics, metabolomics, all that sort of thing, and they assume they have this perception of what's happening out in the field, but they never actually go out in the field. They never have much hands-on experience with growers, and they don't really even know what the growers are facing. But they have in their mind particular problems they want to work on. So they tend to be much more separate or not connected to what the practical aspects are today. And that's a big gap. And if you're going to have your organization where you have all these teams, then you have to have people that translate in between them and very good communication to make anything practical come out. In our situation, where you have one individual working pretty much on a problem, they have to be able to get in the field, and they have to appreciate the importance of getting into the field, because unless you get into the field and actually see what the grower is facing, they're going to do stuff in isolation.
Can I answer just shortly?
Francois, you are taking full advantage that you are president of ICHS. Okay, please go ahead.
No, I fully agree with you on your last point, Ted. Really, it's main concern, and we have to take care about that. Now, on your first point, of course, when I presented, I said, okay, it's my situation. So yes, we are quite lucky to get that. But if I think it's very important, I think what we should do at ISHS, if you are in a small team, I think it's good to see what is the network around you to work with, because working alone and doing everything is my own view. It's in also we are lucky, and Marta mentioned about the European project in Europe. We are lucky to get this European network, and if it works, it's perfect. Now, I understand your point, but I think it's very important to try to develop a network. I stop here, George.
Thank you, Francois. I would like also to give the floor to Professor Brown, who wants to make some statements.
All right, thank you. Thanks, everybody. Good to see you, Ted. He's one office down from me, on the other end of the Zoom line. A couple of observations I've made in the chat. You can read those separately, but I would be interested in the panelists' thoughts about remote sensing and the manner in which we can get extreme levels of data information these days. And it reminds me of the approach that epidemiologists, ecologists, environmental scientists would use to research, where observation very often precedes hypothesis development. And a case in point, I'm working closely with a number of remote sensing specialists right now who are making lots of observations across almond growing regions of California, trying to derive the variables that are driving variability in yield. And often those scientists, Troy Magny, Yufeng Jin, people that Ted knows quite well, will say, look at this, we have a signal coming from here that is explaining a good deal of our variability. With that information, I and other agronomists and horticulturists can go back into the knowledge of the horticulture and say, that's interesting. That's implying, in the case of almonds, that this very narrow confluence of bee activity, bloom overlap, is the primary driver of our yield in any particular year. Data at a level of integrity that we couldn't have hypothesized nor created an experiment to investigate. And I think we have to recognize in the complexity of the agricultural systems we deal with, plant, soil, air continuums, in a genetic system that we only moderately understand, we are going to have to go to large-scale observational data analysis, which is very often observation driving hypothesis rather than hypothesis driving experiment. So I would be interested in what the panelists think about, almost not throwing away, but really refocusing our experiments from old-fashioned Fisher, ANOVA, t-test, experimental plot into an epidemiological and ecological and econometric approach to science.
Very
Speech.
much. Thank you very much, Professor Brown. Ted?
Anyone want to take that? I agree, Pat. There are lots of tools now, and we have access to data that we never had before. And even originally, if you go back, any reasonable hypothesis has to start with some observation. In many cases, a lot of the stuff we do, we first observe and then we develop, and that observation is more like you're talking about. You're developing a hypothesis based on some observation, and then you go on and formulate your tests for that hypothesis later on. So I don't think that's fundamentally different than what's been done over the period, over the years. The only thing I would argue is that that's one way of doing it, and I think if you're truly plowing new ground, so to speak, with this kind of data collection and so forth, then I think that's exactly what we should be doing. On the other hand, I think that for many of our students, they don't want to go through the grueling gut work of reading a bunch of papers and understanding what's been done in the past, and we have a much greater problem in general getting people to recognize that a paper that was actually published in 1980 is not really ancient history. If the paper is older than 3 or 4 years, they assume that that's old stuff. But there's a lot of really, really good old stuff in literature that's 50 or 60 or 70 years old. And developing, starting from the questions and the work that's been done is one way of doing it. If you're indeed plowing entirely new ground, like you're suggesting, with collecting a whole different kind of data set and looking at things in a different way, I agree with you 100%. But that still doesn't negate the fact that eventually then you have to come together, create a hypothesis, and then further test that hypothesis, probably with some of the same technology you're talking about.
Yeah, good point. And Francois, I hope I don't quote your most famous French scientist incorrectly when Louis Pasteur says chance favors the prepared mind. It's sort of an encapsulation of this. It's observation with eyes wide open can lead to true novelty.
I just read your comment on the I fully agree with all what you're saying. Yes, it's you also wrote, it's a dynamic process, and going up, going down, or down, observation and back. Yes, very dynamic one, which makes our job very good, very enthusiastic. Yes.
It also illustrates that we've got to be very careful of those who just do remote sensing, record realms of data and get them published with no horticultural or pomological interpretation. And there's an awful lot of that out there.
Yeah.
Very nice. Moving to the last part of the webinar, I will give the second round the floor to the panelists, starting from Stephania, who also raised her hand. So some brief observation, and if possible, the panelists to check out the comments in the Q&A session, and if they wish to address some of them. So, Stephania.
Okay. I have seen a lot of questions that it would take a lot of time to answer all the questions. But what I want to add is that speaking about Europe, and specifically speaking about Italy, since in Italy the extension in agriculture is often poorly organized and coordinated, recently the so-called third mission of the university has been defined, and to establish connection with the end user of science, so making research results more accessible and to facilitate the transfer of knowledge and innovation and to promote agricultural business. But at the end, the third mission introduces a new duty for academics that, despite the ambiguous definition of third mission, align with the role of extensionist. So again, I think that our research system is mixing all, and everything is important, but each category, each activity, each, step of the long route from basic research to application needs different way to be evaluated. So I fully agree with Marta that we should start, at least in our countries, we should start thinking to a different way of evaluate the research activities.
Thank you, Stephania. Daniel?
Yeah, thank you. Thank you for very lively discussions. Very, very interesting. I'm just going to come back with the issue about I think Ted and everyone said the importance of the students engaging with the stakeholder, with the clientele. I think it's our responsibility to really connect with them and making them sure that when a grower speak with a student, the grower doesn't have much time. So the grower will say a few words which are probably filtering so many of his or her experiences through so many years. And then it's up to the student to translate that information if there are issues to question that could lead to some research that will be either applied, translational, or even basic. Growers now, I don't know, I've heard about in California, many other in the US, are facing critical challenges in terms of cost of inputs, climate, lack of water resources, prices, import, export. So they're struggling. So if we keep the model based on just pure publications or H index on those things, we will have some issues. And the disconnect between the stakeholders and then the academia that Ted posed very nicely is real. So, and if we have maintained a disconnect, we have to remember that many of the practices some of the growers are using are following some of the chemical companies, consultants, and so they have a relationship with them. So we actually need to cultivate that to make sure that they think about us in academia, they think about the value of what we do and the impact to the environment, impact to the people. But we're facing some critical challenges. And of course, the other is the how to align this with the vision of the institution or the agencies. So we need to make sure that if the agencies are supporting into this, we need to cultivate that, because sometimes it's very difficult to say, well, if university A or B or C place a big emphasis on the H index or citations, well, I mean, either we need to maintain the education to the college committees on promotion and tenures, to really realize what is the value of that number within your discipline. So I think we have a lot of work, but especially concentrated on the young generation, because there is less horticulturists coming into the pipeline as students, and it is very critical that we engage those in many of those aspects. And industry collaboration with growers, I think, is going to be very important, and it all depends also on the funding, of course. But yeah, so we need to keep that in mind, and in terms of interaction with who are our stakeholders, and then cultivating those.
Great. Let's go to Chayce and then to Marta for their concluding remarks.
Yeah, I agree. I think that what we've been saying as a group here is a lot of it comes down to communication. And I think as long as we have our mindset set appropriately, that we're supposed to be focusing on hypothesis-driven results, we can't expect, I really liked what Marta was saying, where we're talking about how it's important that the students actually get opportunities to be able to see how the industry functions. And I think that's not going to be on the student, because the student's not going to know how important that is. And so from faculty, primary investigators, it's going to be important to put students in situations where they can interact with the industry that they're supposed to be helping, because otherwise all we're doing is just strict science that may or may not actually apply. And the other thing, like Ted was saying, is that students aren't going to want to sit down and go through all of the old quote unquote literature to see if their idea actually holds water, or if it's already been done before, it's been proven that it doesn't work. It doesn't matter if that's what they want to do or not, it's what's necessary. If we're talking about hypothesis-driven research, then we need to be able to form good hypotheses. It's not just forming any hypothesis. And so I had the privilege of being given a few months when I started my PhD to really dive into the literature, to be able to come up with a base of knowledge, so that when we did come up with a hypothesis, it was a lot better. And that's helped me out a lot. And so for early students, I think giving them an opportunity to do that as well would be tremendously helpful.
Thank you, Chayce. Just to let you know, the panelists and Ted, there are many nice points in the Q&A session. So please try also to address if you think that you can reply to some of them. Now giving the floor to Marta.
So I don't have anything to sum up. I think everyone covered everything quite well. I think I just have a few recommendations for young researchers and young horticulturalists. First of all, please stay curious and be patient because the scientific process is long. Results take a long time to be observable, but they can also contribute to technological development and to major breakthroughs. So keep going and maintain an open mind for exploratory research because often the unexpected results are the ones that lead to major breakthroughs. And secondly, invest in your communication skills. Learn to present your findings in formats that are accessible both to scientists and practitioners. Engage with growers, with agribusiness professionals, and with policymakers. This is very important because with their feedback, you can guide your research to meaningful applications. And networking is key. Attend conferences, go to workshops, go to open days to create your own network of relationships with both researchers and practitioners. And I think that lastly and most importantly, be resilient and open to change because the path of a researcher is very ungrateful sometimes. Sometimes your setbacks can be a little bit frustrating and discouraging. So keep going because you are doing it for the great of horticulture.
Thank you very much, Marta. Just to let you know that I highly appreciate biologists. I have two with majoring in biology in my research group. And you spoke about early stage research. It's a real pity that we are not able to attract many people with who have major in agronomy, in horticultural crops in specific. So we seek people with background in biology, with background in chemistry, to come and complement our expertise. I will give now the floor to Patricia for her concluding remark.
Okay, I'll use my time to answer a question that is in the chat. So this question is from Alberto Ramos Luz, and there is two parts. The first one, his question about the lack of interest of young people on both sides, applied or scientific, and what we can do for them. For me, I think example is one thing very important, and you must to engage young people in everything we're doing in the university and the research centers. What we do in our university, we have some scholarships for young students. When they start their course in the university, they may apply for this scholarship. And the conditions that the student must be involved in our research. So if you have some young people involved in research since they start their course, I think it's a way to engage them and to show our example. In our side, since you are researchers and professors, and you attend meetings with lectures and publish papers, this is a very good example for the students. And they can bring, well, one day I can do the same. I would like to do the same. I think this is fundamental for them. The other part of his question is about how can you support students to conduct genuine and meaningful research. What I say is that I think supervision, advice for the students is very important. And what I'd like to say is that ISHS, in the society, I'm vice president in charge of Young Minds. We are working in creating a very nice program for these young people. It's a mentorship program. In this program, one of the goals is to give them some advisor on their research project and help them in their career. So I think this, to talk with some senior people and ask them for advisor, I think it's very important to help them in preparing very well their research and, of course, their paper.
Thank you very much, Patricia. Ted?
Yes, I was looking at a few of the chat things. One, Stefano Masacci brought up the H factor business. And my advice, we all have to recognize we're in horticulture, and many of us are in relatively small areas of horticulture. If you think about it, I mean, there are only I don't know how many pomologists there are. I'm in pomology. I don't know how many pomologists there are in the world, but there's not that many. And there's even fewer of them that read anything. And so the idea that we're going to have high impact factor papers, if we're working on, kiwi fruit or peach or pomegranates or something like that, it's just not going to happen. And so I want to encourage people not to focus too much on their impact factor, especially when you're young, and just focus on doing really good, solid research, and you will be recognized for it over your career. But don't get too hung up about the impact factor. I think, unfortunately, our institutions and many of our colleagues, if you're in a department like mine, I have 80 colleagues in the department that I used to be in, 80 faculty, and most of them are now very basic. And in basic sciences, they can have thousands of people that will read your paper, but in some of ours, very small, we're basically preaching to a very small choir. And so we have to recognize that that's going to impact our impact. That's going to have an impact on those numbers. And so don't get hung up on that. I just say focus on doing good research and as much as possible, not worry about that. I also really appreciated Marta, and several of us have been talking about networking and the importance of network. And I'm going to put a plug in for ISHS here. We sponsor about between 30 and 40 symposia a year. And I really encourage all of us, all of you to engage in particular working groups and symposia, and don't look at the symposium and say, well, I'm not sure that one's worthwhile this year because I look at it and it's not so exciting, blah, blah, blah. I think for me, it was important to engage in several different work groups within ISHS and stick with them and try to get to their meetings whenever they melt, if it was possible. And it really helps to learn colleagues around and have colleagues around the world and interact and do this interaction, because it's going to be difficult to do, increasingly difficult, I think, to find people to interact with within your close neighborhood. Because as horticulturists in many of the traditional areas anyway, there are fewer and fewer of us. And so reaching out at the international level has really been beneficial for my career, and I highly recommend that you do that. And in terms of this forum, I appreciate all of your inputs, all of the discussion. I hope it's been valuable and interesting for you. I particularly want to thank the two young mind contributors. You added a lot to this, and your perspective is really important for us. And I encourage you to encourage the other people in the Young Minds Committee and Young Minds in general to engage in this sort of thing, and tell us old people how we can better interact with you and engage with you in the future and with students. I think it's really important, and I particularly wanted to have you two in this conversation because of the topic. Anyway, thank you very much. And I'd like to thank all of the panelists again. Anyway, that's it. What do you, George?
Thanks, Ted. I will give the floor to close the webinar to Francois.
Thank you, George. I was very happy all along the seminar, but after during your conclusion, Ted, I became very, very angry. All what you said, exactly what I would say about networking. It's very important. I think we have a role to do at ISHS on top of what you are saying, part of our events, to help making this link between the upstream and again, to come back on the topic, to make the links between the upstream and the applied research. We have to find something. And all our events actually are built for that. The people are coming from different areas. But I think we have really to work on that. And I also would like to come back on our two young mind people. Really, I really appreciate your input. When you speak not as young mind, you speak as very mature people. It's very, very important and we really have to learn from you for sure. Chayce, you raised first one point on communication. For sure it's crucial, and so we really have to work on that. So we since Ted spoke about everything on ISHS except communication, so I go on that. So we will make a lot of efforts on that, and try to answer you. And we really need your input on that to help us to better communicate to all the community, and especially for the young mind. So yeah, thank you very much, everybody. Thank you very much, George, particularly. He did always big work, and it's always well organized. So thank you very much, and Ted for everything. Thank you.
Thank you very much. Have a nice evening. Bye-bye.
Thank you, everyone. See you soon.
Thank you.